I'll move into this AS 9100 revision D requirements, what it is, how it is different from the basic quality management system ISO 9001. I'm going to highlight a very few important requirements, additional requirements. This standard includes entire requirements of ISO 9000 and 2015. A lot of industry specific requirements are added by IAQG. Those are all identified in bold italic font in the standard. When an organization implementing this 9100, if there is any conflict between the customer requirements, the applicable regulatory requirements with respect to aviation, space and defense, and of course this 9100 standard, so which take precedence? The standard made it very clear. So first adhere the regulatory requirements, then focus customer requirements. The least is the standard requirement. Whatever written in 9100, it's only a complementary requirement. It's not going to alternate. It's not giving any alternative to your customer or regulatory requirement. That clarity is made it by IAQG itself. There are some unique requirements they have added in the standard. I'll start with some of the key terms and definition used in 9100, which is pretty new in other industry. This is unique to AS 9100. The very first requirement is the counterfeit part, critical item, key characteristics, product safety, and special requirement. AS industry has their own definition for these terms. I'll go one by one. The counterfeit part. This is one of the serious concern. Nowadays, a lot of counterfeit parts are observed or identified in the ASD supply chain. So what exactly this counterfeit part is? Look at this definition. An unauthorized copy or even imitation or a substitute or even modified part which is knowingly misrepresented. The key word here is knowingly misrepresented as a specified genuine part of an original manufacturer or authorized manufacturer. For example, false identification of a part, false labeling, false grading, false serial number, false date code, false documentation. Anything if you are doing knowingly misrepresenting a product as a genuine part, those are all counterfeit part. Typically in an aerospace supply chain, can you just tell who or where these counterfeit parts are identified? Where exactly these counterfeit parts are exist in the aerospace industry supply chain? Can anyone just type the counterfeit part? Where do you think these counterfeit parts are exist? In an aerospace supply chain, there are various stakeholders is involved. Let's start with the customers, the organizations. We have a suppliers, right? Subcontractors, vendors, correct. So vendor creates, or we can get the counterfeit from vendors, right? No, yeah, MRO, yes, that's another good answer. How about organization who is implementing AS 9100? Typically, let's take a vendor. You are getting a counterfeit part from vendor. The vendor is also an organization. They may also practicing a quality management system, or of course even AS 9100. So what standard trying to address here is we need to prevent the counterfeit part, the entire supply chain. The entire supply chain. It starts from primes to the tier 1, tier 2, tier 3, MRO. So across the supply chain, we need to prevent the counterfeit part. That's what the whole this particular term is. Then critical item. We have seen a particular aircraft system or subsystem has a lot of components goes into it. Plenty of item goes into it, which are all critical. Anything which affects safety, performance, form, fit, function, producibility, service life, this can be called as a critical item, which has some significant effect, either providing the product or using the product, right? But most of the time what will happen, the supply chain may not aware the product what I am producing, the product what I am delivering to my customer, is it a critical item? The engineering authority, designer has to declare whether the item is critical or not. So when we do a contract review, or when we do a request for proposal or whatever the quotation, during that stage itself, we need to identify whether this item is critical or not. We need to ask our customers. It's not just asking and identifying a critical item, what we are going to deal with that critical item. So there are some requirement in 9100. The standard is asking us how to manage these critical items. It may be a safety critical item, mission critical items, even of course key characteristics, right? So this is one new terminology which is used in 9100. And of course, K characteristics. This term is used in other industries too, automotive industry or various industry. We call it as special characteristics, critical characteristics, right? So this standard using this particular term, key characteristics, where the variation has significant effect on my product fit, form, function, performance, or even producibility, that needs some action. The ultimate purpose is I have to control the variation. So for this purpose only, we have a separate standard, AS 9103. Again, that's a guideline, but organization can consider. Again, this is also we have to go and reach, ask to our customer. In this part, is there any key characteristics? So this is another term which is used in this particular standard, critical item, key characteristics. Then product safety. You have seen safety, reliability. These are the two key terms we need to focus with respect to AS 9100. So this is the definition given by IAQG. What is product safety? The state in which a product is able to perform its designed or intended purpose without causing any unacceptable risk or harm to persons or even passengers, or damage to the property, whatever we could say. Typically in aerospace and defense hardware consists of lot of parts, different type of parts. Each part may be delivered from different type of suppliers. So everyone playing very important role in the overall safety of the final product. A small component manufacturer who just do a machining, if I am not maintained the control, the variation, it may affect the next subsystem. The subsystem, one of the critical item in a main system. So that's how the connection is there. Again, who is responsible for product safety in the supply chain? When we say it's everyone. We cannot say I'm not designing anything, so I'm not responsible for product safety. So this standard emphasizes a lot about product safety in this requirements. Yeah, examples of product safety. We could say when I'm doing just small machining a component, I'm trying to meet the drawing specification. So when I'm handling this product, unfortunately or mistakenly, I've dropped the product on the floor. But how are we going to deal with these type of products? Is this a non-conforming product? Who is going to identify it? Dimensionally, as per engineering drawing, the product is perfect, but I have dropped it on the floor. So how about reliability of the product? So these type of questions we need to ask when we are establishing a aerospace quality management system. This is another term, special requirements. Yeah, requirements we know. Customer requirements, regulatory requirements, QMS requirements, right? So a lot of requirements we know. What is the special requirement? Again, this requirement is specified by your customers or even by the own organization to manage high risks. For example, I'm going to tell you some special requirements. Some customer says you have to do this outsourcing process like welding with only NADCAP accredited source. Even the organization may have in-house welding facility, but the in-house welding facility may not have NADCAP accreditation. So the customer put the special requirements. High risk, you have to do only with the NADCAP accredited source. So we are going to see that what is NADCAP end of this training session. Even some countries says you have to procure this raw material which is milled in these countries or only NATO countries. These are some of the examples of special requirements. Either it should be identified by the customers or even organization can identify on their own. It's based on the risks, how we are going to deal the risks. Yeah, is my voice is clear? Thank you. Yeah, so I'll start with a few specific requirements. So far, we have seen just terms and definition. Now we are going to see what are the unique additional requirements. There are a lot of requirements. I have selected very few topics here to discuss now. I'll start with one by one. The first one is addressing customer and regulatory QMS requirements into your own quality management system. Customer QMS requirement, regulatory QMS requirement. See, most of the aerospace industry, they flow down the quality management requirements to their suppliers. We call them as a supplier quality manual or even customer specific requirement, right? So every customers, every aerospace customers needs to flow down the requirement to their supply chain. So when we are establishing a quality management system, we need to ensure those QMS requirements are captured in our own QMS. For example, a record retention, we'll start with the basics. Usually when we develop a management system, we'll try to see what is the customer specific regulatory requirement or customer specific record retention requirement, product specific requirements. Typically aircraft has a lot of lifetime. So how we are going to deal with this? So we need to ask our customers. It's not only a record retention of our own organization, how we are going to deal with your supplier record retention. You might have outsourcing some processes. For example, your customer says you have to retain the record for 35 years. We might have did some outsourcing activity, right? For that particular part, maybe welding or some heat treatment. How we are going to ensure the supplier who did this welding and heat treatment, they are also keeping this record retained for 35 years. So you ask them to keep it or you retain those documents on your end. So those type of clarity we have to address in our own QMS. So like this, a lot of customer QMS requirements are there. So we need to go and ask our customers what it is. Is it applicable for our project? Is it applicable for this particular contract? So that clarity we need to have. The second one is regulatory QMS requirement. Yeah, this is very unique. We have seen a lot of regulatory authorities exist. We have DGAQA in India, DGCA, right? So even these organizations developed quality management system requirement. Let's take example of DGAQA. DGAQA have developed a standard, they call it as AFQMS, approval of firm, based on this quality management system. So what they did is they took entire AS 9100 requirement, IAQG requirement, and they have added their own requirement. So I'll just show some sample. Maybe I'll switch the screen. Just check the screen is visible. If yes, type yes. Yeah. Yeah, are you seeing this? Yeah. Have you seen this AFQMS 2018 document? Or just PPT? Yeah. So this is one example of regulatory QMS requirement. Most of the time we well versed with the customer QMS requirement, but in the AS 9100 this is very crucial. So AFQMS is applicable to people who deal with military applications. So again, they are also focusing quality, safety, reliability. So what they did is they took entire AS 9100 revision D, the text of entire AS 9100 revision D, and they have added additional requirements to it. So this is one example of regulatory QMS requirement. So when we are establishing a quality management system, it is our responsibility, it is organization responsibility to identify those regulatory QMS requirement and customer QMS requirement and include that in your own quality management system. Okay, I'll back to this PPT. Is it visible now? Yeah, thank you. So that is one. The second one is management commitment on-time delivery and product conformity. Okay, have you seen this word on-time delivery in any management system? Either ISO 9001 or IATF or any standard, in any management system standard as a requirement, have you seen this term OTD? Yeah, yes, of course, TL 9000 has it because of their requirement manuals. Any other standards? Yeah, a lot of sector specific standard, specifically IRIS standard, TL 9000, they have this stuff on time delivery. See, IAQG is also taking that particular OTD. IATF, I don't think the word on time delivery is there in that IATF standard. Maybe I'm not sure. You can check that once again. So the on time delivery, they give this commitment to top management. So it is responsibility of the top management to ensure product conformity and on-time delivery are measured. Every organization measuring is. That is not a deal here. But what the deal here is, it is a responsibility of the top management to ensure if OTD and product conformity are not achieved, or you are going to know that it will not be achieved, we need to take appropriate action. So it is responsibility of the top management to ensure appropriate actions are taken. For example, this corona impact. So most of the OTD, we are very clear it is not going to be up, right? So what the action top management is proposed? So what is the role of top management here? So that commitment, they are expecting it from the standard. Then infrastructure work environmental requirement. This is very crucial in this business. Typically, infrastructure work environment, we are well versed with, right? 7.1.3 and 7.1.4. We are more focusing on machineries, equipments, right? IT facilities, and then the complete temperature, humidity. But when we do aerospace, I'll talk with simple example. So you do a machining a component, or you do some PCB assembly, or you do some welding activity, whatever it is. So what is the required room temperature? Is it for the product? For example, welding means what standard I'm going to follow? Is it AWS? If I'm doing PCB assembly, what standard I need to follow? Is it IPC standard or GST standard? So what is the temperature requirement for the product? I'm doing inspection, right? So to do this inspection, what is the illumination I need? What is the lux level I have to maintain? So this context we have to consider with respect to this infrastructure and work environment. Is my voice is clear? Somebody's commenting it's not audible. Okay, thank you. Yeah, if you feel it is cracked, maybe this is recorded already. I'm going to share this recorded video also, right? But please stay connected. Then competency requirements. Yeah, of course, there is not a specific additional requirement with respect to competency, but what IAQG wanted us is, we need to periodically review the competency requirements. Most of the standard CSS determine the competency needs. Yes, of course we determine, but we need to periodically go and review it, because industry standards are keep on getting changed. Yesterday I need the NTT personnel should be qualified as per ASNT, and today the industry standard may call for no, we need to qualify it as per NAS 410. So we need to go periodically and recheck the competency needs based on the customer requirements, based on the regulatory requirements and all. Okay. The next is awareness on product safety and ethical behavior. So this is a unique requirement in AS 9100. Product safety contribution. We have seen the definition of product safety, right? The entire supply chain is playing a vital role in product safety. So everyone in the organization must aware about what is their contribution to achieve the product safety requirement. I may be working in stores, I may be working in machining activity or in final packaging, or I am designing the product, or I am inspecting the product, whatever my role, what is my contribution to achieve the product safety? That awareness we need to create. The second awareness is very important on ethical behavior. See, the counterfeit part and this awareness on ethical behavior, this has a strong connection. If the organization is practicing unethical practices, so how the person is going to deal with this? So this awareness under 7.3, these awarenesses are mandated by 9100. We are already aware about that. There are people should aware about policy, objective, what is their contribution to achieve the objective. Those are all there in the basic QMS standard. But IAQG specifically wanted that everyone in the organization must aware about their contribution to achieve product safety, product quality, and the importance of ethical behavior. This is one unique requirement we have to flow down to the industry. Then project management, there is one more additional requirement there. Typically, the standard doesn't use the word project management, but it says as appropriate to the organization, as appropriate to the product, as per customer requirement, we should have a planned, systematic approach for the operational planning activity. This may be called as project management or program management or even APQP. Automotive industry having their own APQP standard, but now recently IAQG, not even SAE or the primes, they started to comply AS 9145. Recently, there is a separate standard developed by SAE. AS 9145 tell us APQP and PPAP for aerospace and defense industry. That standard is now used by most of the aerospace prime. Even Airbus, Boeing mandated this to their supply chain, few of their tier 1 or tier 2 suppliers. Now people are moving towards this practicing 9145. So these three topics I have highlighted in bold. I'm going to discuss a lot about these three topics. Then I'll move to supplier management. Then we'll cover the rest of the three topics. Supplier management is one of the key critical factor in entire AS 9100. If you read AS 9100, they made it very clear. The organization is fully responsible for the product quality. Either you purchase it from your customer approved source, or you are getting it from even your customer as a customer supplied property, or you are purchased it from AS 9100 supplier, NADCAP accredited supplier. Nothing will play any role here. It is your responsibility to ensure the product are meeting the requirements. So the responsibility fully lies with the organization. So we need to apply suitable risk approach here. When we are selecting a supplier, when we are using a supplier, we have to play this risk management concepts, right? So they are highlighting few requirements with respect to supplier management. And in addition to that, we have to flow down, like how your customer is flow down the quality management requirements to you, and that is the input for your own quality management system. Similar way, as an organization, we have to flow down our own quality management requirement to our suppliers. And of course, if any supplier is dealing critical item key characteristics, your supplier does not have authority to do any disposition on non-conforming product. Your supplier has to reach you. What I need to deal with this? I got a non-conformity. Am I authorized to do rework? Or I can scrap it as it is. So those decisions needs to be taken by the engineering authority, mainly the designer. So these type of the requirements we have to flow down to our suppliers where appropriate. So I'm just touching this another three important topics: prevention of counterfeit part, and product safety, and FOD control. Let's see this in some more detailed way. Yeah. So what is FOD? Foreign object debris or a foreign object damage. This is the term used in ASD business. Debris. It may be any substance or alien to the component or to the system or an assembly that could cause some damage. That is called as foreign object debris. And foreign object damage, any damage or incident which is already happened, it can be expressed physically or even economic terms, or even that may degrade the product quality or safety. Those are all called as foreign object damage. What 9100 wanted us is, we need to have a process to prevent the FOD and detect the FOD and control the FOD. So these three phases, they are expecting an organization to have a process. So what is typically this FOD is? For example, a machined product, the organization is applying some oil for rust prevention or so whatever the purposes. Unless specified by the customer engineering drawing, this rust prevention oil become an FOD because it's an alien, right? So these are some of the considerations we need to have when we are establishing a quality management system. We should have a process to prevent, detect, remove this FOD. This is some of the example of FODs. This picture is taken from IAQG material only. See, these are the FODs observed in an aircraft during MRO, during maintenance, repair, overhauling. Typically, these are all not in the engineering specification, right? And this, look at this. A small broken metal piece causes big disasters. So FOD can be exist anywhere in the supply chain, anywhere. It may be a scratch mark, it may be a fabric from our cloth. So it's mainly important in assembly. When you do any product assembly, that product is airworthy, we have to be very careful. The standard doesn't say you should have a clean room or you should have a controlled environment and all. It depends on the product, depends on the engineering specification. So we should have a process for this FOD. Even for example, if you do PCB assemblies, typically we are more, some of the people, not more, some of the people are most religious, right? They apply all this Vibhuti, Kungum, Chandur and all. Na? So if you do assembly, what will happen? So this risk-based thinking is required throughout this application of this quality management system standard. Maybe you can have a no jewel policy, whatever, it's up to the criticality of the product we need to consider. Okay, so this is what there is separate guidelines available, AS 9146, which tell us FOD prevention program requirement for ASD industry that may be adopted. Again, some of the customer may put this in a contract. If my product is critical, you have to deal the FOD as per 9146. But typically, these 8 primary elements will help us to prevent FOD. This is a guideline, not given in the standard, but is used in the industry best practices. So during program management, consider it prevention of FOD. During operational planning, consider it. Which area? So you can designate the area, bifurcate the area, production areas. The main important thing is training. Everyone in the organization should know about FOD. So typically the awareness on contribution to the product safety is connected to FOD also, right? And of course, good housekeeping is always help us. How to preserve the product, how to protect the product, accountability of items, that is very important. See how many components I received from stores, how much consumed in operation, 10, 20, 30, right? Even during assembly and all, kitting, how many I have kitted from stores, how much consumed, what happened to the damaged part, excess quantity, shortage, everything we have to consider. Tool accountability also. These are some of the best practices used in the prevention of FOD. Okay, so this is what with respect to FOD. Any specific questions with respect to FOD? Yeah, product production with respect to FOD, right? For example, if you keep the product, machined products, how you are going to design the container? If the one product touches each other, so that may create some physical damage, right? Some scratch mark. So those type of things we have to consider. Yes, yes, sir. 2 more board subject. We have time up to 1, right? Uh, See, FODs, yes, it is a regulatory requirement. The definition of FOD itself vary. FAA have a different definition, our DGA, QA have a different definition, right? But the basic definition doesn't change. They have their own requirement. We might have heard about some of the airport, the transit bus causes damage to the aircraft, right? Now this bus itself an FOD, right? Yeah, during FMEA, we have to consider prevention. There is one of the tool we have to consider. That's what program management we have mentioned. The very first step is when we do an APQP, when you develop a new project, you have to consider all the options, how to prevent the FOD. Okay, sir. So I'll move to the next topic now.